Hello everyone, welcome back to my channel Physics for AB. So today we are going to discuss about the periodic properties and how does it varies in a group and a period. So we have a periodic properties over here, that is the first the valency, next atomic radius, ionization energy, electron affinity, electronegativity, electropositivity, metallic nature and non-metallic nature. And how, let us see how does this get changes in a group and period, that is whether the values that whether it gets increases or gets decreases, that we are going to see today. And first, what is the valency? As valency we have discussed it before in our previous episode about the valency is nothing but the combining capacity. As if we see the valency electrons is nothing but the electrons which are present in the outermost orbit, as these are the valency electrons. And coming to the valencies, the respective valency is 1 plus 2 plus 3 and as usual 4. And coming to here the valency electrons 5, we have minus 3, minus 2, minus 1, and for 8 we have 0. So the valency is nothing but the combining capacity, as I have given you the example before. Like sodium we have plus 1 and chlorine we have minus 1. So plus and minus gets combined together to form a compound called NaCl. So that is nothing but the valencies are nothing but the combining capacity. So that is what we have an example here with the NaCl. And if we see here the valencies which are having the plus 1, plus 2, plus 3 are said to be called as the metals, and these metals have the electropositivity nature. So the valencies which are having plus 1, plus 2, plus 3, so these are the metals which have the electropositivity nature. And next one is coming to the valencies as minus 3, minus 2, minus 1. So here the minus 3, minus 2, minus 1, which are the negative values, which are the non-metals, and these are the electronegativity in nature. So the definition of electronegativity that we will be seeing in the next in this session. And next, coming for the 0 last, is that is the inert gases. So as the valency is 0, that means it doesn't have any combining capacity. So the inert gases like helium, neon, argon, krypton, xenon, so these won't get combined with any of the elements. And here we have the middle, which is the valency of plus 4. So plus 4 has the properties of the metals and the properties of the non-metals. That is, the properties of metals and non-metals are combined here, which are called as metalloids. So which are called as metalloids. So the another name for the metalloids what we can call is as semiconductors. So semiconductors like silicon and germanium, so these are called as the metalloids, which are also called as the semiconductors. And the metals which are also called as the conductors, and the non-metals which are called as insulators. So now you got an idea about what is the valency, and the valency plus 1, plus 2, plus 3 are the metals which are called as the conductors, and the valency 4, which is the metalloids, which are called as the semiconductors, which have the properties of the metals and non-metals. And the minus 3, minus 2, minus 1 are the non-metals, which are also called as the insulators. And the valency 0, which is the inert gases like helium, neon, argon, krypton, xenon, so which doesn't get combined with any of the elements. And next, now coming to the next property that we are going to discuss is the atomic radius. So atomic radius is, as we know that it is nothing but the radius, that is the distance from the center of the nucleus to the outermost orbit. So as if you draw a diagram on atomic structure over here, so this is the nucleus on the first orbit, the second orbit, or consider we have another third orbit also, and here we have an electron which is present in the third orbit. Now the atomic radius is nothing but the distance from the nucleus to the outermost shell. So distance from the nucleus to the outermost cell is nothing but we call it as the atomic radius, and this atomic radius is measured in picometers. So it is measured in picometers. So picometer is nothing but 1 picometer is equals to 10 to the power of minus 12 meters. That is, you need to memorize this. So 1 picometer is equals to 10 to the power of minus 12 meters. Now how does the atomic radius changes is in that in a group from top to bottom it increases, and in periods from left to right it gets decreases. So how does it increase and how does it decreases? So let us see over here. As if you see in the periodic table, so we have the periods 1, 2, 3, 4, 5, 6, 7. So these are called as periods, and the vertical rows are called as the groups, and these are called as the periods. So the periods always starts from left to right. So remember that the periods always moves from left to right, and the group starts from top to bottom. As if you see, if we have from top to bottom, here we have hydrogen, and here we have lithium, here we have sodium, and here we have potassium, so on so on. We have the elements which over here. So here if we see in a group, I'm telling about the in a group, say hydrogen have first only one is present in the first period. That means it has only one shell in its outermost orbit. That means hydrogen consists of only one shell. Coming to the lithium, it has two shells. Coming to the sodium, it has three shells. Coming to the potassium, it has four shells, and so on. Coming to the last, which is the cesium, so which has seven shells in its orbit in atomic structure. So as if you see from top to bottom, as the number of shells increases, as I have shown you here, as the number of shells increases, so the size also increases. That is what we say, that in a group from top to bottom the atomic radius is increasing. That is, it increases. And what about for periods from left to right? So periods from left to right, as periods from left to right, what we are saying is it gets decreases. So why we are saying it decreases? As for example, if we see here, we have is sodium, and here we have magnesium, and here we have aluminium, silicon, phosphorus, sulfur, and chlorine, aluminium, silicon, phosphorus, sulfur, chlorine, and here we have argon. So if you see here, sodium, which has 11 electrons, magnesium, it has 12 electrons, aluminium 13 electrons, silicon 14 electrons, phosphorus 15, sulfur 16, chlorine 17, and argon 18 electrons we have. So if we draw the atomic structure of a sodium, like this is the nucleus, and first orbit, second orbit, and third orbit. So we have 2 electrons in first, 1, 2, 3, 4, 5, 6, 7, 8. We have 1 electron in its outermost orbit. It is nothing but the sodium, which is the atomic number 11, and here we have total 11 electrons, and we have 1 electron which is in the outermost orbit. Now coming to the magnesium, 12 electrons. That means another one more electron has been increased. Next aluminium, next another one more electron has been increased. Silicon, one more electron. Phosphorus, one more electron. Sulfur, one more electron. Chlorine, one more electron. And last, coming to the argon, another one more electron. Now total electrons have been increased over here. Now here what you need to imagine is, as the number of electrons increases here, the nuclear force of attraction, that is the nuclear attraction which is present to the nucleus and to the electrons which are in the present outermost orbit, gets attracted and their size gets decreased. So their size get decreased. Why? Because as the nucleus attracts the electrons in the outermost orbit, as the electrons gets attracted, so the size of the atomic size gets on decreasing. First, when it was 1 electron, so it was of this size, but when the electrons gets increases due to the attraction of the nucleus, slowly the atomic radius, that is the shells, get decreases. So that is what we say, that in periods from left to right the atomic radius gets decreases. Why? Because due to the increase of electrons, the nucleus attract all the electrons towards its center. So due to that, the atomic radius gets decreases. Now here we have two questions here, which is the bigger size, Na or Na plus 1, Cl or Cl minus 1. So which one is the bigger one, that we need to find out now. Now for example, now we have taken sodium. So sodium, which has a nucleus, the first orbit 1, 2 electrons, the second orbit 1, 2, 3, 4, 5, 6, 7 and 8, and another one electron. So this is the atomic structure of a sodium with the help of electronic configuration. When we write the electronic configuration, 1s2, 2s2, 2p6, 3s1. Now what does it mean by Na plus 1? As I told you before about the Na plus 1. So Na plus 1 is nothing but the removing of one electron from its outermost orbit. So when we remove one electron from your outermost orbit, then when we remove the electron from outermost orbit, so first shell, second shell, 1, 2, 3, 4, 5, 6, 7, 8. So the outermost orbit has been removed. Now compare the size of Na and Na plus 1. Now what do you think, which is bigger one? Whether it is Na or Na plus 1? Yes, obviously it is Na. Why? Because here we have 3 shells, but here we have only 2 shells. That means the size varies over here. So by comparing this, what we can say is Na is greater than Na plus 1. That is, the atomic size of the sodium is greater when compared to the atomic radius of its ion, the positive ion. Clear? Now next, coming to the negativity, there is the anion, that is Cl and Cl minus 1. So which one is the bigger one, that we need to see here. So let us see, let us take the chlorine, the atomic electronic configuration, 1s2, 2p6, 3s2, 3p5. So when you draw the atomic structure, first orbit 2 electrons, second orbit 1, 2, 3, 4, 5, 6, 7, 8, and coming to the last orbit, so in the outermost orbit we have 7 electrons. So 1, 2, 3, 4, 5, 6 and 7. So as usual, we have got the 7 electrons in its outermost orbit. Now when we add one electron into it, so when we add one electron, it becomes Cl minus 1, and when you see the size of the atom, 1, 2, 3, 4, 5, 6, 7, 8, 8. So 8 electrons has come now. When you compare to the size of the chlorine, Cl minus is the bigger in size. Why we have to say the Cl minus is bigger when compared to the chlorine? Because see here in this, here we have 17 electrons and 17 protons, but when compared to the Cl minus, here we have 18 electrons and 17 protons. As the number of electrons are greater, now the nuclear attraction between the nucleus to the outermost orbit has been decreased. Why? Because the number of electrons are greater. If it is lesser, as if you see in this case, here we have, as the atomic number is 11 electrons, but now when one electron has been removed it, so we have 10 electrons and 11 protons. Now the protons are more, so as there is strong attraction, so all the shells has been decreased over here. But when you compare to here, in this case, so here we have 17 electrons, 17 protons, which is a neutral one. but when one electron is been added, so we get 18 electrons, but protons are 17. Now who is domination here? The electrons are dominating the protons. So the nuclear attraction, which is from the nucleus to the outermost shell, has been decreased. That is due to the decrease of the attraction, so the size has become enlarged. That is, it has become bigger. So that is the reason why we get Cl minus as bigger when compared to the Cl. Why? Because the nucleus gets attraction gets decreased. Why? Because as there are more number of electrons, so 18 electrons we have it. And here the nuclear force, that is nuclear attraction, increases. Why? Because the electrons has been decreased and the protons are more. So protons are which are present in the nucleus, which are center. So the protons are the main role, main play act to maintain the size of the structure. If the electrons are less and the protons are more, then the size will be less. If the electrons are more and the protons are less, then the size will be more. Why? Because the protons are less, so less attraction. Here the protons are more, so more attraction. So I think you got an understand about what is meant by atomic radius. Is it clear about now the atomic radius? Yes. Now next, coming to the next one, which is called the ionization energy. So ionization energy is nothing but the energy which is required to remove an electron from the outermost orbit of a neutral gaseous atom. That is, for example, I have a neutral gaseous atom like some M. Now I am applying some ionization energy. By applying some ionization energy, what I am here is an electron has been removed out, so we get plus one electron has been removed out. This is what we call the first ionization energy, IE1. And the same second ionization energy is nothing but the same, M plus 1 plus ionization energy, we have Me plus 2 plus 1 electron, which is called as the second ionization energy. So ionization energy is the energy required, that is the energy which we need to remove an electron in the outermost orbit of a neutral gaseous atom. So that is the electron which is present in the outermost orbit. So as if you see here, we have an electron in outermost orbit. Now to remove an electron in the outermost orbit, the energy which is required to remove, the energy which is needed to remove, is said to be called as the ionization energy. So that is what we call the ionization energy over here. And we compare the first ionization energy and second ionization energy. So when we remove an electron, we get M plus 1, and when we remove another electron from the same, we get M plus 2. Now in this case, first ionization, second ionization, who is greater? So obviously the second ionization energy will be greater when compared to the first ionization energy. Clear? Why? Because here in second ionization energy we need to remove total 2 electrons. Why? Because second, that means 2 electrons moved out. When in first ionization energy only 1 electron has to be removed. So that in this case second ionization energy is more when compared to the first ionization energy. Now here in this case we have the sum of the ionization energy depends upon few factors, So what are those factors? Let us see. That is the first one, the nuclear charge. So in this nuclear charge, more ionization energy. So how can we say more nuclear charge, more ionization energy? See, I will explain you with an example. So we have a sodium and we have a chlorine, and sodium has 1, 2, 3, 4, 5, 6, 7, 8, and here we have 1, 9, and 10, 11. So we have one electron in its outermost orbit. So sodium has only 1 electron. So we need to observe only this electron which is the outermost. So here we have 3 shells, and here also for chlorine also we have 3 shells. That is, in these 2 cases we have 2 same shells. Now coming to that, the outermost orbit for sodium we have only 1, and for chlorine we have 7. 8, and here we have 1, 2, 3, 4, 5, 6 and 7. Now we have 7 electrons in the outermost orbit of a chlorine. Now nuclear charge is nothing but the, what we can say in our easy language, what we can say is the unity. Like in our lower class we might hear about the story of the cows and a tiger. If all the cows and the bulls are unity, the tiger cannot come near to it. But if they are being individually and they are being divided, like a diversity, so one becomes weak, the group becomes strength. Have you understood now what I am saying? The one becomes weak, that is, as it is becomes weak, so no need of much energy to remove an electron from this. But when you compare to the chlorine, so chlorine we have in the outermost orbit we have 1, 2, 3, 4, 5, 6, 7. 7 electrons we have. That is, now to remove an electron in a chlorine atom, we need more ionization energy. So for more ionization energy, why we require more ionization energy? Because the remaining 6 electrons are being combined with the 7th electron over here. That what we call as the unity as strength, what we say in our language, the unity as strength. So that is what we call that the nuclear charge. Nuclear charge is nothing but the unity which is present in it. And to remove an electron, so we need more ionization energy. Why? Because all these 6 electrons will be holding that 7th electron over here. So just like how we like for suppose in a thread they have 1, 2, 3, 4, 5, 6. So 6 for example, these are the electrons, 6 electrons which are in the present outermost orbit of an chlorine, and I am removing 1 electron from them. As I am removing 1 electron from them, so these remaining 6 electrons are get combined together to hold that electron. That means it doesn't make the electron to get escape. So that is what we call it as the nuclear charge. And in our language we call it as the unity as strength. So here to remove an electron we get more ionization energy. That is more nuclear charge, more ionization energy. So that is one of the factor of the ionization depends upon one of the factor which we call the nuclear charge. So here in sodium we have one electron which can be easily removed, but in this case more nuclear charge, that is more unity of strength, so it becomes more ionization energy, and it is difficult to remove an electron also. So in chlorine also it is difficult to remove an electron in the outermost orbit of the chlorine. So this is about the nuclear charge. Next, coming to the screening effect, or also what we call as the shielding effect, is nothing but the more shells with electrons between the nucleus and valence shell, they act as a screen and decrease nuclear attraction or valence electrons. What we say screening effect is nothing but the number of shells present between. Like for example, if I take for lithium, so lithium has only 1 and 2 shells, only 2 shells in its atom. 1, 2, 3. So lithium, when we take lithium, it has only 2 shells, 1 and 2. But when coming to the cesium, so cesium is having, when we see the periodic table of that, so when we see the periodic table, so lithium has lithium is present in second period, so 2 shells. As cesium is present in 7th period, that means it has 7 shells. So we have to draw 7 shells for it. 1, 2, 3, 4, 5, 6, 7 and so on. So as there is no place I cannot write, so assume it as there are 7 shells around it. Now for example, 1 electron is present over here, and here we have one more electron which is present in lithium. So this is for cesium. Now cesium has more shells. Now what happens when it gets increases? See, in this case the electron is strongly bound with the nucleus, that is, there is a strong nuclear attraction. Now, to remove an electron in this, it's possible but very difficult. That means we need more ionization energy to remove an electron. Why? Because the middle nucleus is been attracting to it. Now, when coming to in this case, the nucleus and the electron is far away. As the distance increases, the attraction gets decreases. As you might have learned in the gravitation chapter, the distance between the two objects, when it gets increased, the force decreases. So when there is less distance between them, the force increases. So as the same also here also, as the number of shells increases, so the ionization energy gets decreased. That is it is easily to remove an electron over here. When compared to the lithium has two shells, it is difficult to remove an electron. But as in cesium there are more number of shells. As the more number of shells is nothing but the more shielding effect, then less ionization energy. So simply, easily we can remove an electron. So no need of having much more energy. Just one click, an electron will be removed easily out here. So this is about what we call the shielding effect. Shielding effect is nothing but as the number of shells increases, the attraction between the nucleus and the outermost orbit of an electron decreases. So this effect is called as shielding effect, and easily this electron can be removed out. So more the screening effect, less the ionization energy. So I think you got clear about what is the nuclear charge and the screening effect, or what we call the shielding effect also. And next one, coming to the next factor, which is the penetration power. So the penetration power is nothing but the orbitals belong to the same main shell have different power towards nucleus. Like for example, the same shell. Now if we take the same shell as fourth shell, in that fourth shell we have the orbitals like 4s, 4p, 4d and 4f. So here we have four different shells. So these four different shells have the four different power, that the 4s is greater when compared to 4p, and this 4p is greater when compared to 4d, and 4d is greater when compared to 4f. That means the ionization energy for 4s is more when compared to 4f. Now if we take an example for beryllium, so beryllium atomic number is 4, as we write the electronic configuration as 1s2 and 2s2. And coming to the boron, we have the electronic configuration as 1s2, 2s2 and 2p1. Now when you compare in these two, beryllium and boron, now here outermost we have 2s, right? And here in outermost we have 2p. As they both belongs to same shell, 2s and 2p, can you tell me whose energy, will be more? That is their different power. That is the 2s will be having more power when compared to 2p. So 2s will be having more power when compared to 2p. So as it has more power and it has less power, so the electron which is present in the p orbital can be easily removed out. Why? Because it has less power. And in 2s it has more power, so it is difficult to remove an electron. So when you compare to beryllium and boron, can you tell me which in which element the easily electron can be removed out? Easily we can remove the electron. Yes, 2p. Why? Because 2s has more power, so we need more energy. 2p has less power, so we need less energy, so easily we can remove the electron over here. So that is about the penetration power of the orbitals. And next, coming to the stable electronic configuration. So stable electronic configuration, that is the half filled and full filled elements. Like for example, if we take oxygen atomic number 8, 1s2, 2s2, 2p, 4. And when you compare with the nitrogen, 1s2, 2s2, 2p3. So this is the electronic configuration for nitrogen, and this is the electronic configuration for oxygen. 1, 2, 3 and 4. Now ionization energy is more for them which is half filled and full filled. like as I told you before, the half filled and full filled will be stable. Like if you see in this oxygen and nitrogen, so this is more than half, right? So if you see in this box, 6 electrons can be filled. Here we have 4, which is more than half. But in nitrogen, 1, 2, 3, 3, that is half filled. So as this is half filled, it need more energy to be filled. That is, it has more ionization energy. But here we have less ionization energy. So you need to remember that the half filled and the full filled elements which are more stable and they require more ionization energy. And next, last factor for the ionization energy is the atomic radius. So atomic radius, more atomic radius, less ionization energy. As I told you before in the cesium, see, as the radius increases over here, as the radius increases, less ionization energy, so easily we can remove an electron. So less atomic radius, it is having more ionization energy. That means it is difficult to remove an electron. So this is one the factors for the ionization energy. So the ionization energy factors, which is the nuclear energy, the screening effect, or what we call the shielding effect, and the penetration power, the stable configuration, and the atomic radius. So atomic ionization energy is measured with the units of kilojoules per mole, or it is also measured with the electron volt per atom when it is measured in ionization potential. Now in groups and periods, how does it increase and how does it decrease? Let us see. So in groups, the ionization energy decreases, and in periods the ionization energy increases. Is it clear now? Nice. Now next, going to the next topic, that is the electron affinity. So electron affinity. So till now what we have discussed is the atomic radius from top to bottom, it gets increases, and in period from left to right, the atomic radius decreases. Next, ionization from top to bottom, it gets decreases, and left to right it gets increases. Clear? Right. Now next, coming to the next, that is the electron affinity. So electron affinity is the opposite, quite opposite of the quite definition opposite. The definition of the ionization energy is quite opposite with electron affinity. So that is the energy liberated when an electron is added to the neutral gas. So in ionization energy, what we say, the energy required to remove an electron. But here the energy is been liberated, or the energy is been electron is been added. So which is also called as the electron gain enthalpy. So when we add an electron, so we get minus, that is M minus, and plus some amount of energy is been released, that is electron affinity energy is been released. And the electron affinity factors is same just as the ionization energy. So there are no separate factors. So same, the ionization energy, what factors do we have? The same we have for the electron affinity also. And in groups, from top to bottom is decreases, and periods from left to right is decreases, which is same as for the ionization energy. So the same as for ionization energy, which is decrease, and here which is increase. And next, coming to the electronegativity. So electronegativity is nothing but the tendency of an atom to attract an electron towards itself when it is bound to the another element. Like the same example I'm showing you, so it will be easy for you. So take a sodium atom, 1 2 3 4 5 6 7 8, and here we have one electron, which is the 11th electron. And the same for chlorine also, 1 2 3 4 5 6 7 8, and 1 2 3 4 5 6 7. Now as we know, as we have discussed in the example of like before, in Na plus Cl minus, so Na plus which removes an electron, and Cl minus which gains the electron, which adds an electron, that we have discussed before, right? The same also here also, the electronegativity is nothing but the tendency of an atom to become a negativity or to attract an electron towards itself, another element. Now for example, if we take this as Na and Cl, now Na plus Cl, when they combine together we get as NaCl, right? So we get as NaCl. So how does this occurs? That is, the electron which is present in the sodium should be removed out, so it becomes as Na plus 1. Now the electron which is present in this should be added, so it gets as Cl minus. Now the plus and minus combines to form as NaCl, right? Now how does this chlorine get an electron? It doesn't get an electron from any other shops or any other friends or relatives. It gets the electron from the sodium. That is, as the electron which is present here, it gets attract. What is the definition about it? It gets attract towards itself. That is, the electron which is present in the sodium gets on attracted to the chlorine. That is, this chlorine, what he will do is, as he need an electron, what he will do, he will attract the electron with the other person who is coming to get bond with him. Now, as when the electron is being attracted to it, now the chlorine becomes Cl minus 1, which is called the electronegativity nature. And this electronegativity nature can be calculated with the help of Millikan's formula. So Millikan formula is nothing but the ionization energy plus electron affinity by 2. By calculating this, we find the electronegativity nature of the elements. And for competitive exams, you may get this as most electronegativity is the fluorine, and the least electronegativity is the cesium. And in groups and periods, groups from top to bottom it get decreases, and in periods from left to right it gets increases, which is same as for the ionization energy and also for the electron affinity also. So it gets decreases, and here it gets increases. Now can you tell me for the electropositivity, it is quite opposite to the electronegativity. So here in a electronegativity, which is attract the electrons, here it attracts the electrons. Electropositivity, yes, it loses the electrons. So it is quite opposite. So as it is decrease and increase, the opposite of electronegativity is nothing but increase and decrease. And coming to the metallic nature, the elements which have the positivity is nothing but the metallic nature. That means the electropositivity and metallic nature both becomes same. So increase and decrease. And coming to the non-metallic nature, so non-metallic nature is nothing but the negativity nature, as we have discussed earlier. Non-metal is nothing but the negativity nature. So it is same as for the electronegativity. So electronegativity we have decrease and increase. So here also we have decrease and we have increase over here. So this is what we have discussed about the the periodic properties of all the elements. And coming here to the valency, from top to bottom the valency has no change. So there is no change. Why? Because from top to bottom the valencies will be plus 1. Like for example, if you take here in the periodic table, so here Na is nothing but the valency plus 1. So for hydrogen plus 1, for lithium plus 1, for sodium plus 1, for potassium plus 1, for rubidium plus 1, for francium plus 1, so cesium plus 1, all these have the same valency, so there will be no change. But from period, from left to right, it get increase and then it gets decrease. That's what. No, from here we get plus 1, plus 2, plus 3, plus 4, then we get minus 3, minus 2, minus 1, and last coming to the 8 it gets 0. That is what we call it as decrease. So in this session what we have discussed it about the valency we have discussed it, and next we have discussed about the atomic radius, and which is the Na plus 1, which is the smaller and which is the bigger, Cl minus 1, which is bigger and which is smaller, that we have discussed it. And next we have discussed about the ionization energy, the energy which is required to remove an electron. In this, the ionization energy factors, which are the most important thing, there's the nuclear charge, the screening effect or the shielding effect. That is next. Next is the penetration power, and next is stable electronic configuration and atomic radius, and next is electron affinity and the electronegativity nature. So this is what we have discussed till now. So right now, thank you for your time. If any doubts regarding, please subscribe the channel, click the like button, and any regarding the doubts, please give a comment. Your doubts will be clarified. Thank you, and thank you one and all.